أعزائي طلبة وطالبات الثانوية العامة القسم العلمي لغات رياضيات، أهلا بيكم في حلقة جديدة من حلقات برنامجنا برنامج كالكولس. النهاردة إن شاء الله هنناقش مع بعض موضوع methods of integration. سبق وتعرفنا على الانتجريشن وعرفنا إزاي نقدر نطبق البيزك رولز على أي فانكشن عايزين نعمل لها انتجريشن. النهاردة إن شاء الله هنستخدم methods مختلفة شوية، نشوف لو أنا مش قادر أطبق الرولز اللي أنا اتعلمتها قبل كده، إزاي أقدر اشوف ميثودز من تو ميثودز هنتعلمهم النهارده، طريقه السبستيوشن او طريقه البارتس انتجريشن باي بارتس، اقدر من خلالهم اعمل انتجريشن لاي فانكشن تجيلي بكل سهوله وبساطه. Dear students of grade 3 secondary, welcome to our maths program. Today we have calculus. Our lesson today is methods of integration. We start with differentiations. Let function f be differentiable on an open interval containing the value x, and delta x is denoted for the change in x where delta x doesn't equal 0. Then the differential of y is denoted by the symbol dy equals f dash x delta x, and the differential of x is denoted by the symbol dx equals delta x. So dy equals f dash x dx. It is a function in two variables. The first variable is x and the second variable is dx. For example, if y equals x to the power 3, then dy equals 3x power 2 dx. The differentiation of y is dy, and the differentiation of 3x power 2, the differentiation of x power 3 is 3x power 2 dx. The two variables 3x power 2 and dx. Let's start with the first example. Find the differential for each of the following. Number 1, y equals 2x to the power 5. Number 2, v equals 4 over 3 by r power 3. Number 3, y equals e to the power 2x minus 3. And number 4, y equals between two bracket 2x plus 5 all to the power 4. Number 1, y equals 2x to the power 5. Then dy equals the differentiation of 2x power 5 is 5 multiply 2x power 4 dx. Then dy equals 5 multiply 2 equals 10 x power 4 dx. Number 2, v equals 4 over 3 by r power 3. Then dv equals the derivative of 4 over 3 by r power 3. We know that 4 over 3 by is a constant, and the derivative of r power 3 is 3 r power 2 dr. Then the differentiation of v equals dv, and the differentiation of 4 over 3 by r power 3 equals 4 over 3 by multiply 3 r power 2 dr. Then dv equals 4 by r power 2 dr. Number 3, y equals e power 2x minus 3. The differentiation of y is dy equals the differentiation of e power 2x minus 3 equals 2 e to the power 2x minus 3 multiply 2 dx, the derivative of the power. The differentiation of 2x minus 3 equals 2 dx. Then dy equals 2 e to the power 2x minus 3 dx. Number 4, y equals 2x plus 5 between two brackets all to the power 4. The differentiation of y is dy, and the differentiation of the bracket 2x plus 5 all to the power 4 equals 4 multiply 2x plus 5 all power 3 times the differentiation of the function inside the bracket. The differentiation of 2x is 2 dx, and the differentiation of 5 equal 0. Then dy equals 4 multiply 2, which equals 8, times between two brackets 2x plus 5 all power 3 dx. Now, the integration by substitution. The integration by substitution, it's one of the most essential methods of integration to find the integration of the product of two functions in the form f of g of x times g dash x dx. If z equals g of x is a differentiable function, then differentiation of z, which is dz, equals g dash x dx, and integration of f g of x times g dash x dx equals integration of f of z dz. Find integration of x power 3 multiply between two brackets 2x power 4 minus 7 all power 9 dx. By putting z equals 2x power 4 minus 7, the expression inside the bracket 2x power 4 minus 7 equals z, and the differentiation both sides dz equals 8x power 3 dx, and the differentiation of 7 equals 0, then 1 over 8 dz equals x power 3 dx. Now we can substitute in the original function. Integration x power 3 times 2x power 4 minus 7 all power 9 dx equals integration 1 over 8 z power 9 dz, because 2x power 4 minus 7 equals z, and x power 3 dx equals 1 over 8 dz. The function now in terms of z, integration 1 over 8 z power 9 dz equals 1 over 8 times z power 9 plus 1, which is z power 10 over the new power 10 plus the constant c. Then the integration equal 1 over 8 times 10 z power 10 plus c equals 1 over 80 multiply. We can substitute about z with 2x power 4 minus 7 all to the power 10. The integration equals 1 over 80 times 2x power 4 minus 7 all power 10 plus the constant c. Another example, find integration x plus 4 over x power 2 plus 8x all power 4 dx. Now, by putting z equals x power 2 plus 8x in the expression between the two brackets, then the differentiation of z dz equals the differentiation of x power 2 plus 8x equals 2x plus 8 between two brackets dx. Then dz equals 2 between two brackets x plus 4, we take 2 as a common factor, dx. dz equals 2 multiply x plus 4 dx. Then half dz equals x plus 4 multiply dx. Now the original function, integration x plus 4 over x power 2 plus 8x all power 4 dx, we can substitute about x plus 2 x plus 4 dx by half dz and x power 2 plus 8x all power 4 by z power 4. Then the integration equals 1 over z power 4 multiply half dz equals half is a constant integration z power negative 4. We know that 1 over z power 4 equals z power negative 4 dz. The integration now in terms of z. Then integration z power negative 4 equals z to the power negative 4 plus 1, which equal negative 3, divided the new power negative 3 plus the constant c. Now the integration equals negative 1 over 6 multiply z power negative 3, z equals x power 2 plus 8x all power negative 3 plus c, or the integration equals negative 1 over 6 multiply x power 2 plus 8x between two bracket all power 3 plus the constant c. Another example, find the integration between two bracket 3 minus x multiply e to the power 6x minus x power 2 dx by putting z equals 6x minus x power 2. 6x minus x power 2 is the power of the number e, and we can differentiate both sides. Then dz equals the differentiation of 6x minus x power 2 is 6 minus 2x dx. We can take 2 as a common factor. Then dz equals 2 multiply 3 minus x between two bracket dx. Divided both sides by 2. Then half dz equals 3 minus x dx. The original function integration 3 minus x e power 6x minus x power 2 dx. We can substitute. Then integration 3 minus x dx equals half dz and e power 6x minus x power 2 equals e to the power z. Now the integration with respect to z, integration e power z multiply half dz or half integration e power z dz. The integration of e power z dz equals e power z. Then the integration equals half e power z plus the constant c. Now the second method, integration by parts. If y and z are two functions in the variable x and differentiable, two differentiable functions, then the derivative of the product of y, z with respect to x equals y times dz dx plus z dy dx. By integration both sides with respect to the variable x, then integration the derivative of yz with respect to x dx equals integration y dz dx with respect to x plus integration z dy dx with respect to the variable x. Then yz equals integration y dz plus integration z dy. Now if we have integration y dz equals yz minus integration z dy, and this method is called a rule of integration by parts. Example, find integration of x multiply e power x dx. Now let y equal x and dz equals e power x dx. We can choose y equal x a part and another part dz equals e power x dx. We can divide the function into two parts. The first part x and the second part ex dx. And differentiating the first part, we have dy equal dx. And integrate the second part, integration dz equals z, and integration e power x dx equals e power x. And from the integration, the rule of integration by parts, then y z minus integration z dy. The integration equals integration x e power x dx equals x multiply e power x minus integration e power x dx. The first term x e power x is the integration part, and the second term negative integration e power x dx equals e power x plus c. Then integration of x e power x dx equals x multiply e power x minus e power x plus the constant c, and we can write the result as e power x multiply between two bracket x minus 1 after we take e power x as a common factor between two bracket x minus 1 plus the constant c. Another example, find integration of x power 2 e power x dx. Let y equal x power 2 and dz equals e power x dx. We can divide the function into two parts. The first part y equal x power 2 and the second part dz equals e power x dx. We can differentiate the both sides of the first part, then differentiation of y is dy, and the differentiation of x power 2 equals 2x dx, and integration of dz equals z, and the integration of e power x dx equals e power x. Then the rule of integration by parts, integration y dz equals yz minus integration z dy. Then integration of x power 2 e power x dx equals x power 2 multiply e power x minus integration 2x times e power x dx. The second term is a function 2x e power x dx. We can use the rule of integration by parts another time to find this integration. The relation integration x power 2 e power x dx equals x power 2 e power x minus integration 2x e power x dx, or equals x power 2 e power x minus 2 integration x e power x dx. The second term x e power x integration x e power x dx. Let y equal x and dz equal e power x dx. The differentiation of y is dy equals differentiation of x is dx, and the integration of dz equals z, and the integration of e power x dx equals e power x. Now we can use the rule of integration by parts. Then integration y dz equals yz minus integration z dy. Integration x e power x dx equals x times e power x minus integration e power x dx. This relation x e power x minus integration e power x dx equals x e power x minus e power x plus c. Then the integration from the second equation and the first equation, the second equation e power x multiply x minus 1 plus c, from 2 and 1, then integration x power 2 e power x dx equals x power 2 times e power x minus 2 e power x times x minus 1 plus c. We can write this relation as e power x between two bracket x power 2 minus 2x plus 2 plus the constant c. Another example. Find the integration x power 3 ln x dx. Integration x power 3 ln x dx. We put ln x and x power 3 dx as a two parts of the function. The differentiation of ln x equals 1 over x dx, and the integration of x power 3 dx is x power 4 over 4. Then ln x multiply x power 4 over 4 minus integration x power 4 over 4 times 1 over x dx is the rule of integration by parts. Then x power 4 over 4 ln x minus integration x power 4 over 4 times 1 over x dx. The integration equals x power 4 over 4 ln x minus 1 over 4 integration x power 3 dx. The first term x power 4 over 4 ln x is the integration part, and negative quarter times integration of x power 3 dx equals quarter x power 4 plus c. Then the integration equal x power 4 over 4 ln x minus 1 over 16 x power 4 plus the constant c. Another example. If dy dx equal x sine x over y at any point of the points of a curve, and if this curve passes by the point 0 and 0, prove that y power 2 equals 2 multiply between two bracket sine x minus x cosine x. The relation dy dx equals x sine x over y is the relation between the two variables x and y. Then we can write y dy equals x sine x dx, and the integration of both sides with respect to x, integration y dy dx with respect to x equals integration sine x dx, and the right hand side is integration by parts. Let x and sine x are the two parts of the function. We differentiating x, we have dx, and the integration sine x, we have negative cosine x. Then x multiply negative cosine x minus integration negative cosine x dx. The integration of the left hand side y power 2 over 2 equals negative x cosine x plus integration cosine x dx. The integration of cosine x dx equals sine x, then y power 2 over 2 equals negative x cosine x plus sine x plus the constant c. Now, what is the value of the constant c? Since the curve passes by the point 0 and 0, then when x equals 0, y equals 0. The left hand side, y power 2 over 2, which equals 0 over 2, equal right hand side negative 0 cosine 0 plus sine 0 plus c. Then the value of c equals 0. And y power 2 over 2 equal negative x cosine x plus sine x plus 0. We multiply both sides by 2. Then y power 2 equals 2 times between two bracket sine x minus x cosine x, which is the required to prove. بكده اعزائي نكون استعرضنا مع بعض موضوع methods of integration، وعرفنا ان عندنا طريقتين اقدر استخدم اي واحده فيهم لو عايز اجيب integration لاي function. بس الاول بنجرب الرولز اللي سبق ودرسناها، البيزك رولز اللي درسناها قبل كده عن الانتجريشن. لو كان البيزكس رولز ما بتشتغلش معايا او ما بتجيبليش الانتجريشن، فابدا اجرب او اشوف اي واحده من التو ميثودز اللي اتعلمتهم النهارده، سواء كانت الميثودز الاولانيه اللي هي by substitution او by parts. By these examples we come to the end of our program today, and till we meet again, it's goodbye.